So this is experiment 9, acceleration due to gravity. It's on page 40 of the Physical Sciences Laboratory workbook. So what we're going to do is we're going to drop a couple of objects and try and measure the acceleration due to gravity. What I've got here is a position sensor. So that's going to be our raw data, but the software can also analyze the position data and calculate velocities as well. So we're going to have a look at a position time graph, in other words a displacement time graph, and a velocity time graph for a falling object. So got a few different balls here. Some work better than others. Now normally, in the prac, what you'd normally do is just drop it. Unfortunately, what sometimes happens is that it doesn't necessarily bounce vertically, so it comes out of the sensor's range. So to compensate for that, what we're going to do is encourage it to fall vertically with a tube. So it might just hit the size of the tube every now and then, but it should still be in line with the sensor. Let's just get that all lined up. Okay, so what we're going to do is drop one of these balls. Might just move that sensor up a bit.
Lovely.
Good. So that was the big green ball. We'll try it with a smaller yellow ball.
Beautiful.
Good. And we'll try a golf ball. Does that look straight from where you are?
Yeah. Lovely.
Good. And we'll try a ping pong ball. Which didn't work when we were setting things up, but let's try it again anyway. Well, ping pong ball with holes in. Does that look all right?
Yes. Bit messy.
I'll do that once more. About the same, is it?
Yeah.
Okay. Well, let's go with that for the moment. So, just find the best looking run that we had, maybe the first or second. You can see here, that's where it was being dropped, and that's where it bounced. There's our bounce there. Right, so there's a gorgeous parabola, and that's mind-boggling that you could get such a perfect parabola just from a law of nature. All right, so you can see down in the velocity time graph, what we've got is this bit here. Now, there's a few interesting things here. Note here that the slope of the displacement time graph here is 0, which indicates 0 velocity. And that lines up precisely with the VT graph here, where the velocity is 0. Another interesting thing to note is that the slope of the VT graph, which is acceleration is constant here under the axis and it's constant here above the axis, but those two slopes are slightly different. That's interesting, isn't it? So the acceleration in one direction looks like it was different from the acceleration in the other direction, which should not be the case. I can only guess that we've got the ball maybe hitting the side somewhere, something like that, to slow it down slightly.
It's not air resistance?
It'd be air resistance. The faster it's going, it'd be the more air resistance there would be. So you'd have to think
But
about.
the air resistance is changing direction, isn't it?
It is, yes. Good point. There you go. All right. So what we've got to do is measure the slope of that.
So the whole thing, 9.6. Covered it up a bit. That's a bit awkward. There we go. 9.6.
Right. And we're hoping to get around about 9.8. So that's not too bad. And what about if we just look at the lower half of that?
$10.6.
And what about the upper half?
9.3.
Okay. So we've got.
This is one of the other balls.
So you can see here again, we've got a nice series of parabolas. And we've got zero velocity there lining up exactly with zero velocity here. So let's measure the slope of those two sections.
Like this?
Yeah.
Oh my God. Can you read that, Pete?
No, I can't see it.
It says 9.81.
9.81. How about that? There you go. All right. And what about that second section?
Well, it's only really 3
It's only
points.
3 points. So it's not very reliable.
But it is 9.37.
Okay. Good. So one of the other things I'd like you to see and think about is what is the positive direction? Is the positive direction downwards or is the positive direction upwards? All right. So here's zero displacement and it's getting more and more positive as the ball goes from the top of the tube towards the bottom of the tube. So figure out from that, is up positive or is down positive? All right, so you can have a bit of a think about that one. So what we're going to do is we're going to get you a copy of some graphs that are similar to this, and we're going to ask some questions about it, and you can write your answers through Canvas.
Yes, and we will upload that as a document next to the video?
Yes,
Yes. Is that everything for the video?
I think so.
Okay, fantastic. Thanks, everyone.
Good.
Goodbye.